In the late 1950s, Douglas Aircraft explored the development of a short to medium-range airliner to serve alongside their long-range DC-8. The initial proposal, known as the Model 2067, featured 4 engines and was designed for medium-haul routes, but the project was shelved when airlines showed little interest. Just as this effort faded, Douglas entered into a 2-year technical partnership with France's Sud Aviation in 1960, agreeing to market and potentially license-produce the Caravelle. Yet, when no orders materialized, Douglas resumed independent design studies once the collaboration ended. By 1962, the groundwork for what would become the DC-9, designated Model 2086, was taking shape. The early concept envisioned a 63-passenger aircraft weighing 69,000 pounds, though this evolved into the definitive configuration for the first DC-9 variant. When detailed design work began in February 1963, Douglas moved swiftly, announcing the official launch of the DC-9 program on April 8th of that year. Almost immediately, Delta Airlines placed an order for 15 aircraft, with options for 15 more, and by early 1965, the company had secured orders for 58 units, along with commitments for an additional 44. Unlike Boeing's 727, which borrowed heavily from the 707 to streamline production, the DC-9 was an entirely new design. Douglas prioritized economic performance and future adaptability, ensuring the aircraft could evolve with market demands. Since Pratt & Whitney had a long-standing relationship with Douglas, the choice was a natural fit. To mitigate financial risk, Douglas pioneered a shared production arrangement, partnering with de Havilland Canada to manufacture the wings in exchange for future production guarantees. The development pace was remarkable. The first production DC-9 took flight on February 25, 1965, followed by a second aircraft weeks later. By July, a fleet of 5 test aircraft was conducting rigorous evaluations, leading to refinements such as an improved leading-edge slat design for better aerodynamic performance. When the Series 10 received FAA certification on November 23, 1965, Delta Airlines introduced it into service just 2 weeks later, on December 8. Douglas's swift execution allowed the DC-9 to enter the short-haul market before Boeing's 737, propelling it to become the world's best-selling airliner for a time. By May 1976, 726 DC-9 family aircraft had been delivered, more than double its closest competitor. Although the 737 eventually surpassed it in sales after decades of fierce competition, the DC-9's early dominance was undeniable. The DC-9 was purpose-built for short to medium-haul routes, filling a crucial niche in aviation by serving smaller airports that lacked the infrastructure to accommodate larger jets like the Boeing 707 or Douglas DC-8. With a maximum takeoff weight limited to 36,300 kilograms under FAA regulations of the era, the aircraft could operate efficiently with just a 2-person flight crew. Its cabin featured a practical 5-abreast seating arrangement that could be configured for 80 to 135 passengers, depending on the airline's needs. A particularly innovative feature was the inclusion of built-in air stairs, including a unique tail-mounted stairway, which significantly reduced turnaround times at airports with limited ground equipment. Designed for durability, the original airframe was certified for up to 40,000 landing cycles, though many aircraft would far exceed this benchmark in decades of service. The aircraft's distinctive design featured rear-mounted JT-8D turbofan engines and a T-tail configuration, engineering choices that delivered several operational advantages. By positioning the engines at the rear, Douglas engineers created cleaner wing aerodynamics that allowed for more effective flap deployment, resulting in superior low-speed handling characteristics and shorter field length requirements. This configuration also reduced the risk of foreign object damage from runway debris, though it introduced a potential vulnerability to ice ingestion from the wing roots. The absence of underwing engines permitted a lower fuselage profile, making the aircraft more accessible for ground operations without requiring specialized loading equipment. These thoughtful design elements combined to create an aircraft particularly well-suited for operations at less developed airports. In the cockpit, pilots worked with a fully analog instrument panel featuring manual controls. The aircraft's handling characteristics were carefully engineered to overcome the deep stall phenomenon that had affected other T-tail designs. most notably contributing to the loss of the BAC-111 prototype. Douglas engineers implemented vortilons, small aerodynamic surfaces beneath the wing's leading edges, to maintain proper airflow and prevent dangerous stall conditions at low speeds. This solution proved particularly effective given the unique airflow patterns created by the rear-mounted engine configuration. The DC-9 series, the first generation of what would become a storied aircraft family, proved to be a long-term commercial success for Douglas. Yet, despite its popularity, early production costs exceeded expectations, forcing the company to sell the initial units at a loss. This financial strain, combined with the high demand for the DC-9, made Douglas an attractive candidate for consolidation. In 1967, the company merged with McDonnell Aircraft, forming McDonnell Douglas, a move that would shape the future of commercial aviation. Manufactured in Long Beach, California, beginning in 1965, it eventually shared an assembly line with its successor, the MD-80, inheriting the same production numbering sequence. Though series production of the original unit ended in December 1982 after 976 deliveries, its lineage continued through the MD-80, MD-90, and ultimately the Boeing 717, with the last model rolling out in 2006. In total, the DC-9 family accounted for 2,441 aircraft, a remarkable figure even when compared to the 2,970 Airbus A320 and 5,270 Boeing 737s delivered by 2006. As fuel efficiency became a greater priority in the 1970s, McDonnell Douglas explored modifications to the DC-9, including redesigned wingtips. Yet, these studies yielded minimal benefits, partly due to the wing's inherent design constraints. Between 1973 and 1975, the company tested a quieter, more efficient engine variant, the JT8D109, achieving noise reductions of up to 9 decibels in flight tests. Despite these promising results, no further aircraft were converted, and the test model was reverted to standard engines before delivery. The final iteration, the MD-95, was renamed the Boeing 717 after McDonnell Douglas merged with Boeing in 1997. Though similar in size to the DC-930, it featured modern materials and was powered by Rolls-Royce BR-715 engines. The Douglas DC-9 stands as a testament to thoughtful engineering and adaptability in commercial aviation. Its innovative rear-engine design, short field capabilities, and operational efficiency made it indispensable for regional routes, while its rugged construction ensured decades of reliable service. Though later derivatives like the MD-80 and Boeing 717 would incorporate modern updates, the original DC-9's fundamental strengths, simplicity, versatility, and reliability, cemented its legacy as one of aviation's most enduring workhorses. Even today, its influence persists in modern regional jets, proving that good design truly stands the test of time.